Hello, ladies and gentlemen. Welcome to Collanet Africa. Today we have a very exciting tool to share with you, an interactive periodic table. This is a periodic table that you can click on any element on the interface and it will open for you a pop-up window for you to, see the items. And I'm not going to waste time. Let me just show you what I mean. So let's say, for instance, you're learning about lithium and this is what you see when you click on lithium. You will see an overview information about lithium, its melting point, its boiling point, oxidation states, the year when it was discovered, its atomic mass, the group and period, and things like that. A lot more information. And then you go to the atomic model, you can see the animation of how lithium element looks like, how the electrons move around on the orbitals, and then you can go to the configuration. So the configuration will show you the electron configuration of lithium. So you can see here it's helium in bracket and then 2s1, which means it takes the configuration of the noble gas that comes before it, and then you just do a notation for the outer electron orbitals, and that explanation is given here. So this is not a mistake. When you see He for lithium here, this is what it means, so that you don't go on repeating the notation for that specific elements. Maybe for, I'm going to show you an element that has more orbitals, and how it makes work easier. And then you can see the ions for lithium, uh, its oxidation states, its energies. You can see all that. And then the isotopes, if it has isotopes, you'll see them if they're stable or not stable. And then you can see the energies, ionization, electron affinity, electronegativity, boiling point, and things like that. Then you can go to the properties and you can see where it's used, its solubility, and things like that. Its abundance, where it's found. And then the wiki here gives you a small summary of lithium in narrative so that you can understand a little bit of the history of that element. Yeah, so that is it in a snapshot. So let me just show you why this becomes very important, especially when you're dealing with larger um, elements. Let's say we go to potassium, for instance. Then you can see we only do a notation for the outermost electron configuration, which is 4s1. But then we take the full configuration for argon, the noble gas that comes before potassium. And if you go to the configuration, this is the full notation for potassium, but then the noble gas shorthand makes it easy for us to just pick the notation for argon, that is the noble gas that comes before it, and then we just put the electron configuration for the outermost shell. And that makes it easy for us to do a notation for that element. Yeah, so it's correct, it's not a mistake, and it's not an oversight. Then the isotopes, you can see this one shows you even the half-life for that specific isotope of potassium. So we have 39, 40, and 41, and potassium 40 is the one that is not stable. So you can see the half-life. It has a half-life of 1.25 raised to power 9 years. Um, that's a very long time. Uh, the wiki is here, and you can read more about that element. And it happens like this for all the elements in the periodic table. You can see the atomic model, how the animation works, all the electrons, how they move around the core of that element. Yes, so you can see for all those elements. And then we have filters here at the bottom. If you want to just filter out alkali metals, then you just click that and it will show you there. Then if you want to filter out alkaline earth metals, if you want to transitional, post-transitional metals, metalloids, non-metals, halogens, noble gas, lanthanides, and actinides, you can see all those elements there. Yeah, and each of these We'll still show you the configuration, its ions, if it has isotopes, and all that. Yeah. And this is plutonium. Look at the half-life, 24,100 years. That is plutonium 239. And then if you have 244, it's even crazier, 8.1 raised to power 7 years. Yeah, that's it's very dangerous. Yes. Um, yeah, so that is in brief what we have for you with this interactive periodic table. You can interact with it, you can use it as a teaching aid, a teaching tool. You can use it as a companion because it's also accessible on mobile. You just go to Collanet Africa slash periodic table. But even if you go to the front page, if you just go to the front page, if you forget that and then just scroll down, you'll see here explore cPeriod, and then you go to the interactive periodic table, which is this one here. And that is what I have for you today. Until we meet again in the next tool, let's stay productive, let's stay learning, let's stay connected, collaborative, and moving forward. Thank you.